converting from ratios to fractions. Every proportion is also a statement that two fractions are equal. Okay, so basically what we're doing now is we're getting a proportion and we're equaling it to another proportion. Okay, so example 1, we're going to write the ratios in their fraction equivalent form. Well, we know how to do that. This is going to be the numerator of our fraction, and then the 3 will be the denominator of our fraction. And we'll just set that equal to the other fraction. So that's going to be 2 over 3, bring down the equal sign, equals 4 to 6. All right? So we're just writing it in their equivalent fraction form. Go ahead and try b by yourself and check back with me in a second. That's going to be 5 to 7, 5 to 15 to 21. And there we go. Example 2, write the following fractions in their ratio equivalent form. Okay, we're doing the exact opposite. As usual, this whole chapter has been doing just having you practice going from one form to the other, and then from this other form back to where you came from. Okay? Well, we know how to turn a fraction into a ratio. Just take that first number from your numerator and the second number from your denominator, 3/5. And that's equal. We're just dropping down that equal sign to 9/15. Oops, that's an ugly box. Okay. Go ahead and try b by yourself and check back in with me. All right, that's going to be 4 to 6 equals 2 to 3. All right. Aha, last page. Wonders. All right, 3.4, using proportions to solve for an unknown quantity. Ooh, now we're getting into the fun stuff. It's always fun solving things. Okay, so here's a new concept. Well, some of you may have already seen this concept. I wouldn't be surprised if you had. But if not, here it is. And if you have heard of it, hopefully it's a good refresher. All right, so if you're given this proportion, okay, remember a proportion is when you have a fraction equal to another fraction. That's what a proportion is. So if you're given a proportion, you can solve for a variable. Really? How? Well, by multiplying the first fraction's denominator, b, okay, to the second fraction's numerator. So we'd multiply these two guys. And then setting that equal to the first fraction's numerator, okay, a, multiplied to the second fraction's denominator, d. Okay, now if you'll notice, what symbol did I make when I did this? I made an X, hence where the term cross multiplying came from. All right? So we'll get something that looks like the following. B times C equals A times D. So it doesn't actually matter if you wrote A times D first equals B times C. Okay, it doesn't matter which one you write first. So let's go ahead and do cross multiplying to solve for our variable. So first off, before we ever begin solving for anything, I always ask that you first find out where your variable is. So take a look at A and underline your variable. Well, remember our variable is normally a letter. Okay, and I see that little X hanging out right over there. That is my variable, and that is what we're solving for. So the plan to solve for something is to always get that variable by itself equal to some random numberings. Okay, we always want to get the variable isolated. Well, to do that, our plan is to cross multiply. Why? Well, if you have two fractions equal to each other, the way to simplify is to do cross multiplication. Okay, so it's the simplifying. So we'll do 3 times 1 equals 2 times x. Okay, cross multiplying. Oops, I just changed up the colors there. All right, well, 3 times 1, that's okay, that's 3. All right. Okay, notice I'm keeping my equal signs lined up. That way you, as the watcher, can read. Okay. X is not by itself yet. How do I know that? Well, there's that 2 times x. Okay, 2 times x. I want to get rid of that 2. So how do you undo multiplication? Division. 2 divided by 2 would be 1. So let's divide both sides by 2. Remember, that's the other thing with equations. What you do to one side, you have to do to the other. Okay, so 2 divided by 2, I said, was 1. So that's going to be 3 divided by 2 equals 1 times x. But what's 1 times anything? Just itself. So this is going to be 3 over 2 equals x. And there we go. Real quick, I'm not going to have you check your answer for these. We'll do that a little further down. If you wanted to check your answer, though, actually, you know what? We'll go ahead and check our answer for this problem, and then the rest of them we won't do that. But let's check our answer for this problem. So how do you check your answer? Well, we're going to plug x back in to the problem. So we're plugging this in, 1 over x. And we want to see if whatever we get, do we get 2/3? Well, we said that x equaled 3 over 2, so let's plug that in. That looks nothing like 2/3 yet, but remember we can do this division. That's 1 divided by 3 over 2. And we know how to do division with 2 fractions. You might say, wait, that's not a fraction. Remember, we can put that as 1 over 1. So that's 1 over 1. Oops. And getting rid of the division, we'll turn that into multiplication and take the reciprocal of the end. We get 2 over 3. And then 1 times 2 over 3 is just 2 over 3. Oops, I forgot my equal signs the whole way. So my question to you, when I plugged in my variable, did it end up equaling 2 over 3? Yes, it did. Okay, our work checked out. Okay, so that's how you can check your work. What you do is you plug in your variable and see if when you work it out, does it end up equaling the other side? And in our case, when I plugged in the answer for our variable, 1 over x, I worked it out, and yes, I found out it equaled 2/3. So if this had ended up equaling something besides 2/3, I would know my answer was wrong, and I need to go back and solve it again. Okay, good way to check your answer. All right. So let's go ahead and use cross multiplication to solve for x with this problem. Okay, we'll cross multiplying 5 times x, and then 4 times 7. Well, 4 times 7 is 28, and 5 times x. All right, remember, we want to get x by itself. But at the moment, is there anything near x? Yes, there is. There's that 5, and I want to get rid of that 5. So how do you undo multiplication? Remember, we divide. So we're going to divide both sides by 5 to get that 1, and then divide by 5. So then we have 1 times x equals 28 divided by 5. Well, 1 times x is just going to be x equals 28 over 5. All right, here's a quick question. We're not going to check our answer for this one, but what if I said you need to answer as a mixed number? How would we get a mixed number? Remember, we do the long division. Can 5 go into 28? Well, 5 can go to 28 5 times. That's going to be 25. Then doing the subtraction, we get 3. So we're going to add that decimal point. Can 5 go into 30? Yes, it can. 6 times. So that would be our decimal answer, would be 5.6. What would our mixed number be, though? Well, you wouldn't continue into the decimals for the mixed number. What you would do is you would go until before you'd done the decimal, which would have been right here where my remainder was. So for the mixed number, that would have been 5 and 3 over 5. Okay, so our 2 answers. To get the decimal, you keep going past the remainder when you're doing the division. And to get the fraction, you just stop at your remainder and you don't start adding the decimals. Okay, so those are the 3 possible answer forms depending on what is asked of you in the problem. All right, C, last but not least. Let's go ahead and, real quick, try solve this one by yourself. Pause the video and check back in with me. All right, let's solve this using cross multiplication. 25 times x, 5 times 50. Now remember, it doesn't matter if I wrote it this way or if I wrote it as 50 times 5 equals 25x. It does not matter. Why does it not matter? Because this statement is just saying these two sides are equal. Okay? Just like if I had 2 pens and said these 2 pens are equal, would they no longer be equal if I moved them into this position? No, that doesn't make sense. They're still equal. Doesn't matter which position I move them into, they're still equal. Okay, so that concept works with the equal sign. These are still equal, so it doesn't matter if I switch them around. They're still equal. All right, let's go ahead and solve this. That's 25x equals, well, 50 times 5. You know what? I'm going to leave this real quick. And you'll see why in a second. So, how do we get the x by itself? Well, we're going to divide by 25. Divide by 25. Now I'm going to do a trick. I'm going to divide the 50 and the 25. I know that 25 can go into 50 twice. So 25 can go into itself once, and 25 can go into 50 twice. So that's going to be x equals 2 times 5. Okay, so I shortcutted. I didn't have to do the long multiplication out on the top. Okay, so if you can simplify like that, that's ideal. And then we do 2 times 5, so x equals 10. And that is our answer, and we are done. All right, that is it for chapter 3.